Hi there, my name is Diarmuid O'Connor, and I'm going to be covering the Full Stack Web Development 2 module with you. Now, I met quite a number of you last January at the on-site day, and I gave you an overview of the module then. But of course, you've learned a lot about web development in the meantime. So at this stage, I could summarize what my objective is as introducing you to an alternative to the Svelte framework. In particular, we're going to look at a framework called React. But in terms of prerequisites for my module, it's not that important that you are familiar with an alternative to React. Really, as long as you've got solid web foundation skills, then that's sufficient. And what I mean by that is that you're comfortable with JavaScript, HTML, CSS. And I'd add to that maybe that you're also familiar with the role of the DOM, the document object model, in the browser. And they're the only requirements that I have. We will essentially build on that knowledge. So let's get started and have a look at the website for the module. So the layout of these websites now are fairly familiar to you. Now, in my case, this first card here on the extreme left, behind that really are just the slides that I went through when I spoke to you back in January. So I'm not going to go over those at all, actually, but you might want to flick through them to remind yourselves as to what I spoke about back then. So in this lecture, I'm going to cover this card here, this topic here. And in the case of most of my lectures, there will be an archive accompanying the slides. And the archive is typically behind this card on the extreme right. So the procedure is you click on the card, that downloads a zip. You unzip that archive and you import it into VS Code. You might remember when I spoke to you back in January, I did say that I use VS Code for this module. And all of my labs include screenshots from VS Code. So I'm not sure if Eamon used this IDE, or really it's a text editor more than an IDE. I think Eamon may have used WebStorm with you, but I would encourage you to become familiar with VS Code. It's quite a good thing to have on your CV, so to speak. But either way, for all of my archives, once you unzip them, import them into VS Code and then proceed as I would give you instructions. And I will demo a lot of the stuff in the lectures through the medium of VS Code anyway. The card on the left typically contains my slides, and then the ones in the middle are the labs. In the case of this lecture, it looks like there are going to be 2 labs. Most weeks there's only 1. So let's get started on today's topic. And we are going to be using React version 18, which is the most up-to-date version that was released back in March or April, I think, of 2022. Now, we could just as well use version 17, although there was one reasonably significant change between version 17 and 18. So if you start reading articles around React, you will notice straight away whether it's actually using version 18 or 17, even though the article might not mention it. And I'll point out towards the end of this slide set what one of the differences between 17 and 18 were. Obviously, there were a lot of new features brought in 18, most of which we won't actually get to look at, but there was a fairly low level or fundamental change made in 18, which we will actually notice in our code. So as usual, I'll just give a very quick background to where React came from. Then I'm going to talk about, you may have come across the model view controller, which is a design pattern for structuring our code, and React specifically purposefully decided not to follow this MVC pattern. It only focused in on the V part. I'll explain that in a moment. We'll also talk about something called JSX, which was really the secret sauce, if you like, that React used in its framework, which no other framework, none of its competitors at the time made use of. The React team didn't actually invent, if you like, JSX. It existed as a separate library, but the React team picked it up and made use of it. And really, it's this JSX syntax that resulted in React becoming such a popular framework. There are two tools that we will be using throughout this part of the module. One of them is very much kind of in the background, a tool called Vite, and the other tool is one called Storybook, which we will use today and in this week's lab, although it will kind of drift away back into the background as well as we work our way through this sort of this part of the module. The last topic there, material design. What I've actually done is I've pre-recorded a short presentation on that. I think it's only about maybe 10 minutes at most. And I will tag that pre-recorded presentation on material design onto the end of today's lecture. So I won't cover it in this lecture, but you should go back and just view it yourselves. It is very important because we use material design right throughout this part of the module. So background, well, what is React? As if you probably know at this stage now, but React is what is categorized as a single page app framework. Now that name or that kind of label, single page app, I'll explain where that comes from when we get a little bit deeper into the framework and make sense of the label. There's no point in trying to explain where it comes from now, but that's what it is, and that's how we would categorize it. React actually began as an in-house application in Instagram. This was before Instagram were acquired by Facebook. Lots of tools and frameworks that we use today in the software development world, not just web development related tools now, but more generally, a lot of them actually begin life as in-house projects within organizations. And fortunately, those organizations open source those tools or applications and make them available to the general public, and the general open source community then usually kind of contribute to them and improve on them. And that was the story with React. It wasn't called React back then. This is I guess the early noughties. But anyway, it was an Instagram in-house application that they used for developing their own websites or web apps. Facebook, as we know, acquired Instagram, and when the Facebook people, they liked what they saw and they kind of open sourced it and made it more general rather than specific, special purpose. And that's where it actually began life, and I guess they called it React at that stage, and they open sourced it around 2012. So it's been around for quite a while, but it's still extremely popular in the industry. 10 years is typically the maximum lifetime of any kind of software tool or framework in today's world. So it's noteworthy that React has survived that and is still going strong, so to speak. Now, there are kind of nerdy arguments as to whether React could be classified as a framework or a library. I'm not going to get into it, but it doesn't really matter to us anyway. So React is, I'm saying, this single page app framework, which essentially means it's a framework for developing browser-based apps, right? Now, it wasn't by any means the first single-page app framework available to software developers. There were many of them at this back in 2012 and prior to that. But what was noteworthy about React is that it adopted some very different practices to all of its competitors at the time. So, for example, its competitors might have been Angular, which you may have heard of, Backbone, which was probably one of the first single-page app frameworks that people used, Ember as well. They all, back around the mid-noughties, they all used the model view controller pattern as essentially the way the developers should structure their code. But the React team decided that they were not going to follow that practice. They were just going to focus in on the V part of MVC. So that was one noteworthy difference at the time. also back then, all of the React's kind of competitors used a templating approach towards coding up your user interface. You may have used templating somewhere along the lines. It doesn't really matter whether you have or not, because React decided that they weren't going to use a templating approach towards how you code up the user interface part of your web application. They decided to follow a components-based approach. Now, as it turns out, that was a clever choice, because pretty much all of React's competitors today are using this component-based approach. But back then it was novel, and it was going a different direction. So React is very much focused on V, which stands for view, and it uses a component model rather than a templating model. And there were various advantages that they felt justified the choices that they made, which I'm kind of just mentioning here on the table. I'm not going to talk my way through, but the essential advantages had to do with reusability and composability of your code base. That's really what the kind of table is telling us. I don't want to spend too much time on this advantages, disadvantages stuff. So React is all about building components, and we kind of glue those components together or compose them to make an entire app. That was their model, if you like, which was quite different from the templating approach. So it's all about, as well I'm saying there, it's all about the user interface. This was the idea that they focused on the V part of MVC. As we know, MVC also deals with the area of business logic, and it deals with the area of data management or state management. React doesn't look at those aspects at all. So you need other third-party libraries if you want to have some significant kind of data management part to your web app, data management being the M part of MVC. Now, arguably, business logic should never be part of a browser-based app. Business logic should really reside on the server side, but that's another day's discussion. But in particular, they decided to ignore the M part, the model part. And there are lots of third-party libraries that deal with that. And if you do any kind of Googling on the web, you'll come across maybe references to Redux. There are many, many, many more that all work very well with React, but those other frameworks deal with kind of data management side of your web app. Now we'll slightly break that rule, as we'll see further down the line, but that was the idea back then anyway. So React is about building components. And what do we mean by a component in this whole context? Well, a component, I'm saying, is made up of two parts. It's made up of the user interface description part, i.e., how do we want our component to display on the screen, plus the UI behavior part. Sorry, now just 1 second. Okay, so there's these two parts that comprise a component in the context of React. And what was kind of novel as well was that these two parts that make up a component, they actually were very tightly coupled, and they were co-located. Back in the templating days, you coded your UI description using some sort of templating language. You coded your UI behavior, and by UI behavior I mean what do you want to happen behind the scenes when the user interacts with the component that displays on the screen by clicking or selecting or whatever. But back in the templating days, the UI behavior, was coded in JavaScript, but it was in a completely separate file, if you like, from the template file. And so you found yourself as a developer kind of switching between these two when you were developing your user interface. Whereas in the React world, these two are co-located in the one file because they're they're logically coupled together. They're tightly coupled together. So why keep them separate when they are really part of one thing, the one thing being a component? Yeah, the two aspects are tightly coupled, and that was not the case in other frameworks. And then there are these, again, which kind of relates back to the previous screen. There are benefits to these kind of decisions that the React team made. One, it was much easier to compose components together, to bind them together and get them working together. And also your components would be, it was easy to make them more kind of reusable from within an application or between applications. Now we're just going to focus in on the UI description part. The UI behavior is just JavaScript, you know, some piece of some function that you want to execute to do something. The something can be anything at all. Could be make a HTTP call, or do some computation, or whatever, or indeed change the DOM somehow. So that's just code. But in terms of the UI description, that's what we're going to focus on today, really. And what I'm going to be showing you, first of all, is what I'm calling the kind of vanilla React approach towards coding up the UI description part of a component. But we never like writing vanilla code. But I think it's worthwhile for you to just be aware of what vanilla React looks like, because at the end of the day, that is what the browser executes. It doesn't execute the source code that we write, which will be quite different from the vanilla React code that the browser executes. But essentially, and it does kind of simply boil down to this, there are two methods that the React framework or library makes available to us. And these two are sufficient to code up any UI description part of a component. One is a method called the createElement method. An element here is essentially a HTML element, which translates to a DOM node. So this function, which we'll look at in a second in terms of its parameters, this is the function that you invoke if you want to create a new DOM node. And this here, React DOM.createRoot, is how you essentially attach your new node to the DOM. And as I said at the beginning of the lecture, it's not only when you attach something or make an actual change to the DOM that change is reflected in what you see on the screen. This method up here just creates it in isolation, but this is how we attach it. So taking those two methods, the createElement method, it expects three arguments. One is, what type of element do you want to create? What type of HTML element, essentially. The second parameter is kind of quite generic now. What properties do you want to associate with that element? Now, think of CSS style if you want to attach some CSS style to it. Also, this is where you would indicate what event listener or event handler you want to associate with the element, which I was talking about at the beginning. And thirdly, and extremely importantly, what children do you want that element to have? Because we know HTML is we can nest HTML elements within elements. And so we need to be able to express that nesting as well using this createElement method, because I might want to create a div, and within that div, I might want to have some other sub-elements, a paragraph, a heading, button, etc. And it's down here is how I would indicate what children should be within that div. So we'll see an example of that in a second. But as I said at the start of this slide, okay, this createElement method is what the browser executes when it's running our app, but we never write invocations of this directly in our source code. If we had to, then React would really never have caught on. The second method that I mentioned at the top is this React DOM. I should have probably mentioned the React framework is broken up into a number of separate libraries. One is called React, another one is called React DOM, and there are a couple of others as well. So we will be primarily looking at these two parts of the framework, if you like. The react-dom.create element, sorry, create root method. What I said was the purpose of that was to associate a new element that we created with this method to attach it to the DOM. And so you somehow, and we'll see in a second, you somehow tell it which current DOM node you want to attach your new element to. Let's look at some examples. Now, if I go back to the website, the examples I'm going to look at are contained in this archive on the right there. So if you click the card on the extreme right, you'll download a zip file. And when you unzip it, what you will get is this folder here. Now, I did mention to you way back in January, I'm sure you've forgotten, that I use VS Code throughout this module. And I know Eamon didn't use it, he's a WebStorm fan, but I do use VS Code. I recommend that you use it as well. It's not absolutely mandatory, but all of my kind of labs have screenshots from VS Code. So I'd get into it if I were you. It's good to have it on your CV anyway. So just go to the VS Code website. It's very easy to install. You download it, unzip it, and that's what it really, there isn't really much into the installation procedure. And kick it off. It's just an executable. And so I've done that. Here's my VS Code kicked off. This is what you see when you start up VS Code initially. And VS Code is a text editor, by the way. It's not an IDE technically, but and so if I want to import something into VS Code, I can just do it by drag and drop. So I'm going to drag that and drop it onto my VS Code. And this is what we have. Okay, and I'm just going to look at some of these HTML files now in a few minutes. Just before I do that, there is a README. And the README just has a link to a short little YouTube video there that I made last week. It's only about 8 or 9 minutes. And it explains to you how you should set up VS Code for this this little project. Okay, there is one little plugin that you need to install with VS Code, and the YouTube video explains how you do that. So have a look at that beforehand. Right. Now, I suppose just a minute on maybe VS Code. So in terms of the language of VS Code, this is obviously the editor area. We see our files and our folders over here on the left. Down here is what it calls the panels area. The main thing that's in terms of panels is that you can actually start up a shell session within VS Code, or a DOS session, whatever operating system you use. And I have it here at the moment. I've opened up a terminal session. The way you do that is, and I explained it in the video, how you start up a terminal session, what it calls an integrated terminal session within VS Code. In other words, I just have the ordinary shell command prompt here, and I can submit commands from here, which you will be doing quite a lot of. On the extreme left here is what it calls its activity bar. Now, in terms of activities, the main one is what it calls the Explorer activity, and that's the mode that you will be in when you're doing editing. Down here is the extensions activity, which is where you go if you want to install any plugin, and you will need to do that for this particular little sample project, and I explain in the video how you do that. This one here is its source control activity. VS Code has got really, really good integration with Git. I'm not going to go into it, but it does. Maybe you may have some free time down the line. And it really makes working with Git so much easier. Even though I will do a lot of Git stuff from the command line in the labs, but it does have very good integration, just by the way. Now, I want to get back to the focus of what we're on about here, though. So what I've actually installed is a simple little HTTP web server as an extension to VS Code. And the way I start that web server, and again, the video explains how you do that, is if I click on this link down here, in the status bar. This is what the VS Code calls a status bar. If I click this link here, it's going to start a local HTTP web server, just a bog standard web server now, nothing fancy. And it will serve up the contents of what you see on the left. So let's just do that. And we'll start with the 01 HTML file, which is here. And that's what it displays on the screen. So let's look at that HTML file. So it's a standard HTML file, and it's got a script section in it, and it's really the script section that we're interested in. So what am I doing in the script? Well, first of all, here we go. I'm using React.createElement. Of course, you can see here that I've also got scripts that are referring to my React and React DOM third-party libraries that I've installed in the Node modules folder. I need those scripts, obviously, because here in my own script, I'm referring to an object called React, and that React object is clearly defined inside one of the libraries for me. But in terms of creating a UI description for my web page, essentially, that you saw there, here I am using createElement. I'm passing it a couple of arguments. I'm telling it out, create a H1 HTML element. In terms of properties, these are the properties. Now, class name here is essentially relating to the CSS class that I want to associate with this H1 element. There's a reason why the React team did not use the word class there, because as we know, class is now a reserved word in the JavaScript language. So they had to change it to something else, and they decided to use class name. So whenever you see class name appearing in any of our React code, then just think of CSS class. So I'm associating this CSS class, which I've just defined here in a local CSS file, which isn't that interesting, but that's it there anyway. And technically, language is a child, it's a text node within my H1 node. So that creates a H1 element for me. And I do a little bit more of this. I create a UL element, sorry, an LI element. I create another LI element here and a third one here. Then I create it looks like I create a UL element. I don't have any properties. And this UL element has 3 children, which are my LI elements. So that's an example of the kind of nesting that I was talking about. Then I create a div, and in the div, I've nested the header that I created at the start and my unordered list. So all of this relates to what we saw there on the screen. But of course, it's not until we do these 2 lines here that they actually appear on the screen. Here I'm going where I do React DOM.create. Now, create root here, this is how we attach new nodes to the existing DOM. And so what you've got to pass to this method here is a reference to an existing node on my DOM. Now, if I scroll up, there's really only one existing node on the DOM, which is this one here. It's a div with an identifier. So this piece of code here is really old. Sorry, this is old style. Why does that keep happening? I'm not sure. This is old style browser coding, if you like. I'm essentially asking the document object to find a particular node within the existing DOM for me. And so it will return a reference to that node. Now, the create element then kind of wraps that, if you like. And in the very next line, I'm using what it returns, and I'm calling render. I'm calling render on that. It's a bit clunky as to how we attach a new element to the DOM. It was actually much cleaner in the old approach, but there you go. So React, so that render here, you're passing it, I'm passing it the new element that I've just created, which is this this element here. And it's not until these two lines execute, in particular, it's not until this line executes that my my web page appears as it is. For example, if I comment out this line, okay, and I save the changes, and because I'm using the Go Live server, you know, it will push the update to the browser. If I save and go back to my browser, then certainly I'm not seeing anything. Now that's because I haven't made any change to the existing DOM. But by bringing this back in and saving it, it does appear. So what I've just shown you here now is what I'm calling vanilla React code for creating the UI description of a web page. We actually haven't seen a component yet because this is only one part of a component. Now, if I look at the second page, which is this one here, UI description or O2 UI description, there's no difference in terms of what we see on the screen. If I bring it up, okay, it displays the exact same thing. The code for it is only slightly different, and the difference is, and I'll show it to you in a second, but if you think about it, if I take, let's say, if I take, you know, this variable here, remove that, and instead just substitute in what it's assigned to, or what is assigned to it. If I copy that and paste it in, here, and keep on doing that, do the same for item 2 and item 3, and keep on going. Maybe if I go down here, replace that variable with what's actually assigned to it up here. And similarly for list. If I keep on doing that variable substitution as it's termed, then what you finish up with is this. And this is really the exact same as the previous piece of code, except, you know, we're just nesting invocations of React.createElement within invocations of React.createElement. And you can just study this for a moment yourselves later on, but it is the exact same code and it's doing the exact same thing. And so that's why we're getting the exact same appearance on the screen. So there's nothing new other than I've just slightly restructured my code there in the 02 sample. So if we just at the bottom of the screen, I'm comparing and contrasting two, this is kind of a deviation away from React now for a moment, but there's a purpose behind it. Essentially, when you're doing any kind of programming, there are essentially two programming models. There's the imperative programming model, and there's the declarative programming model. Now, there are others as well. There's a functional programming model. But for the purpose of this discussion, imperative programming and declarative programming are two quite different programming styles or programming paradigms. Imperative programming is what everybody, I guess, that's usually where everybody begins when they're writing code. And the imperative programming model is noteworthy by the fact that you essentially have a sequence of statements, and that sequence of statements is executed in a particular order. In other words, there's a certain flow of control in the sequence of statements, and the sequence of statements change some sort of state within your code. That's fine. an alternative programming model is a declarative programming model. And the way it's characterized is you're not so much concerned with programming flow of control. You're just concerned with programming the logic associated with changing the state from one form to another form. The runtime environment will take care of executing the relevant statements in a particular order for you. So the runtime takes care of the flow of control and the sequencing of statements. What you've got to do as the programmer is somehow describe the logic associated with that flow of control. Now, I know that's very kind of abstract to be talking about these two things, but there are two programming models. Now, arguably, the programming code that I've just shown you there is an imperative approach towards coding my UI description in React. So whether we call it vanilla React or the imperative approach, they both mean the same thing for the purpose of this discussion. And it's quite long-winded and kind of problematic, really. But it's, like I say, it's where everybody begins with programming. Now, fortunately, React has a declarative approach as well. And it's this declarative approach that really caught on, and it's what made React such a popular framework. And the declarative approach, what's central to it is this special syntax called JSX, which is an extension of the JavaScript language. So you can mix JSX code in with your ordinary JavaScript code. And this was this idea that I mentioned a while ago about co-locating the UI description with the UI behavior. So JSX is that's how we as developers write our UI description. We don't use the imperative approach that I've just been showing you, but it's the imperative approach that the browser understands. That's the only one it understands. It cannot interpret the declarative approach. So let's see how we actually write our declarative description for the exact same example. Well, just before I move on to that, I'm also saying here that, okay, we write our React code using the declarative approach, i.e. using JSX, but that has to be transpiled or converted back into vanilla JavaScript, which is what we were writing up to now. So we'll totally look at file 03, but I purposefully put error as part of the file name because the browser cannot actually execute the script that's in this 03 file. Let's look at it first. So this is how we actually describe the UI using JSX. And when you look at it, you'll say that's just HTML. And there is a very, very close relationship between HTML. It's very HTML-like. In fact, this is precisely HTML because there's no dynamic part to this JSX code at all. So we're assigning a piece of, let's call it what it is, we're assigning a piece of HTML to a variable. And then we're doing the same stuff as before. We're binding that new element, that root element that we've created, we're binding it or attaching it to the DOM. Now, the problem is, okay, this code now is JSX code. It's contained within a HTML page. But the problem is that the browser won't be able to interpret it. And let's prove that to ourselves if we try and get it to display that HTML page. And if we open up the developer tools, we're getting an error. And if you study the error, what it's essentially complaining about is it doesn't recognize this as a valid JavaScript symbol where we actually use it in our code. And that angle brackets is the very first part of my JSX. It's this part here. Once it hits that, once the runtime interpreter within the browser sees that character there, it doesn't know how to interpret the assignment statement, and that's what caused it to throw the error. So how do we get over that? Well, what we've got to do is, what we've got to do manually is we've got to take this JSX and convert it to vanilla JavaScript. Now, there are tools, fortunately, that will do that automatically for us, but let's do it longhand first, maybe. A manual way of doing it is, there is this website called babel.js, which you can see here. You won't actually be using it very much. We'll use other tools, but for now, we'll make use of it. And if I click on this, try it out here. What this online tool allows me to do is I can put JSX code in here, and it will convert it into plain old JavaScript over here. So let's do that. Now, what you see on the right is, surprise, surprise, there is react.createElement. There's some extra kind of annotations being added in there as well, which I'm not too interested in. But this is what we need to give to the browser, and it can interpret that, and we've seen that already. So this is manually transpiling my JSX into plain old JavaScript. Now, I did that beforehand. So if I move on to sample 4 in my sequence, this is sample 4 using JSX indirectly, because you can see now what I'm doing is I'm referring to a local JavaScript file that contains my React code, and that's going to be up here in my case. So I've got 204 files. The numbering obviously is to help you to follow this. I've got 204 JavaScript files. One contains the pre-transpiled code, and the other one contains the transpiled version of it. So from the names, you can tell this is the pre-transpiled code. So this is what we will actually be writing as developers. But what is sent to the browser is this, and that looks kind of vaguely similar to what I was showing you in the 01 and 02 samples. So we're getting closer to how we do things in React. This is how we actually write our UI description using this JSX syntax. So JSX is very HTML-like. Technically, it's actually XML. And purposefully, there are very few differences between JSX and HTML. And really, I think there's only one that you will see in the JSX that you write, which is if you want to associate a piece of CSS styling with a JSX element, then instead of using the class attribute, you use class name, and I've mentioned that already. And I think that's probably the only difference between HTML and JSX. There are one or two others, but we don't actually encounter them. And so it allows us to code up our UI descriptions in a declarative style. And as we'll see, eventually we'll be able to inline. Well, I mean, we've seen it already. We can, the sample that I've shown you there, okay, this contains just an assignment statement and nothing else, but this is a JavaScript file. So I could put whatever other JavaScript I want to in here. And eventually we'll see how we can associate what we're doing up here, how we can link it into the code down here. Maybe if I want to, if I've got a variable declared up here or computed up here, and I want that variable to appear in my JSX. It's quite simple as to how we do that. So we can mix JSX with ordinary JavaScript code in the same file. We can co-locate them. Typically, the JavaScript that we write would describe some behavior that we want to associate with our JSX. Just going back to the issue of transpilation, there are two aspects that make up the transpilation for us. One is Babel. Now the second one, Vite. Vite is a tool that uses Babel internally, and we use Vite. It would be quite difficult for us to use Babel directly. We use the Vite tool, and there's very little configuration that we have to do in order to use the Vite tool. But by using Vite, it will take care of transpiling all of the source code that make up our project for us. So in terms of how we do the transpilation, well, we could have used the approach that I was mentioning there a while ago, using the online tool. Clearly, that's not scalable. There is also a command line version of that REPL, but again, the command line would require you to start typing commands at the terminal, and that doesn't scale up either when you've got maybe tens or maybe more dozens of source code files that make up your project. Option 2, which is the option that we will mainly be using, is we will use a web server that is specially instrumented with the Vite library. And what this web server will do for us is it will monitor our source code files, and anytime any source code changes, it will automatically transpile that file, and it will send the updated transpilation up to our browser, which is currently displaying our application for us to view. So you get that kind of user experience of you coding, making changes to your source code, save those changes, and immediately you can switch over to the browser and you see the effect of those changes, because in the background, this specially instrumented web server will take care of doing the transpilation and pushing the relevant updates to the browser. That's often referred to as live reloading. Now, 2 is excellent for when we're in kind of development mode, but eventually we will want to deploy our React app to the cloud so that our end users can access it. And obviously, the kind of experience, the kind of process that's going on in step 2 here is not appropriate for a production version of our app. So what we want to do instead, maybe when we get to production stages, to take our entire React application, transpile everything, and bundle up the entire application into a single unit, and then deploy that single unit. Now, fortunately, the Vite tool comes with a builder or bundler wrapped in it as well, and you will use both of these in the second of today's labs. So what this builder or bundler does is it essentially goes through all of our source code, transpiles everything, and then packages all of our source code into one single JavaScript file, and also performs minification and compression on it, so that we have a much smaller unit to deploy. Now, at the beginning, I said React is all about creating components, but we actually haven't seen a component yet. We've seen one part of this component, which is JSX. So what is a component? Structurally, what is a component? Well, it turns out that it's nothing more than just a JavaScript function, where that function returns JSX as its response. And when you create these special, okay, they're special in one sense, but they're not in another sense. They're just ordinary functions. But because they are returning JSX, we kind of refer to them as React component functions. The function will have a name, but what's nice about it is that we can use that name because it now represents a component which kind of relates to a new HTML element. We can refer to that component using the HTML-like syntax. In other words, in a sense, you could think of creating components as extending the HTML catalog of tags available to us. We can create new tags for ourselves, and we can use those tags in the classic HTML way by wrapping them in our angle brackets. So maybe the code that we've been looking at so far, what it was doing was generating a list of dynamic programming languages. So we might, when eventually we get to put all of that code into a component function, we might call that component function dynamic languages. And now we can refer to that component like this. So we're told to move on to sample 5 now, which is our first example of coding up a React component. Although we're still back in the world of where we take the source code and do the translation ourselves. We don't have a web server that's just monitoring our code base for us. That'll be the next step. But let's look at 0.5. So now I want to look at the HTML first. Then it's a standard web page, and it's, as well as referring to our 2 third-party libraries, we're referring to a local JavaScript file. And again, you can see I have 2 files prefixed with 0.5. This one contains the code that we write. So let's open it up. And as promised, what am I doing? I just have an ordinary function. I'm using the arrow syntax. It doesn't have to be the arrow syntax, but that's what I'm using here. And okay, the body of my arrow function doesn't have any logic in it, but it does have a return statement, and my return statement is my JSX stroke HTML, static HTML in this case. So that is my first component. But again, we cannot send this kind of code down to the browser, so we need to get it transpiled. And when I did that using the online tool, what it generated for me was this one here. And again, we don't really need to study this in any kind of detail, but that is the transpiled version of my component. This is the file that's being referred to by my HTML, from my HTML script tag. And so based on the source that we saw there, okay, this is what it should, and we can see, what it should, how it should display on the screen. And that is what we got when we looked at, it from here. Okay, so that's a component. Now, before I start delving into extending the capabilities of our components, I just want to go off on a slight tangent for a second and talk about the tools that we are going to be using when we're doing our React development, and they're also very popular in the industry. One of them I've already mentioned, which is the Vite tool. And Vite has a number of parts to it. It has what it will do for you is it will scaffold a React project for you. It's kind of a React project generator, if you like. So it'll structure our file system within our React project for us, essentially. Number two, it comes with its own development server, which I've been talking about. And thirdly, it comes with a builder or bundler tool. So it has all that you need to do your React development. This is the first year that I've used Vite. In previous years, I was using a tool called Create React App, and you may come across references to that when you start reading articles on React. They are fine as well, but by far and away, Vite now has kind of taken over from the Create React App tool in the industry because its development server is much more responsive in terms of what it's supposed to do, and also the kind of packages that it generates using the bundler are more compact as well. But Vite is very much in the background. We will do a tiny bit of configuration of Vite, and other than that, we just avail of mainly the development server that comes with it. We will use the bundler this week, but we won't use it after this week. The second tool that we're going to use is a tool called Storybook. Now, Vite is a tool that you use for creating an entire React project, whereas Storybook is a tool that you use when you're developing an individual component. And so what it does, it has many of the same features as Vite. For example, it has its own development server as well. But what's nice about Storybook is you can develop a component in complete isolation. You don't have to kind of artificially stitch it into a React app in order to see how does my component look on the screen? Does it behave the way I want it to behave? You can answer those questions in complete isolation. So you can essentially develop your React component as a unit independent of any other components that might be around it eventually in an app. And so arguably when you're developing components in isolation like that, you actually develop more reusable components and that are better designed. I won't go into explaining why that's the case, but you can imagine anyway, if you're developing something in isolation, you're not concerned with the environment around it, which it works. And I'm going to talk about Storybook a little bit more in this lecture. So how you install it is it's just an npm install, so it comes as yet another third-party library in the Node ecosystem. When you do install it, what you get are essentially two things. You get a web server, and this web server does all of the things that the Vite server does, as in it kind of monitors changes that are happening to your code base and does retranspilation and all of that, performs live reloading. Secondly, it comes with its own web-based user interface, because if we are developing a React component, then clearly we want to see how does it render on the screen, or how does it display on the screen. So Storybook provides its own web browser-based user interface tool that will allow us to do that. And when you do fire up the Storybook server, it will automatically open up a browser tab, and in that browser tab, it will render the Storybook UI tool user interface. And the tool, the browser-based user interface, will essentially show you on the left, it will list all of the components that are part of the project that you're currently working on. And this list is hyperlinked. And if you click on any one of them, then it will show you on the right how that component renders on the screen. And that's really what you want Storybook to do for you. You want to be able to develop your component in isolation. Then when you've done your development, you start up your Storybook server. It will display all of the components that you've developed so far, and you can just click on any one of them and see how they display. And these components are independent of one another. And typically then you go back and make changes to your code for that component, save the changes, and it will be automatically updated in this browser-based user interface for you. Now, the name Storybook comes from the notion of user stories in user requirements analysis. That's the origin of it, which you may or may not be familiar with from other studies that you've done. But if you think about it, if you think about the component that we've developed so far, that little component that lists dynamic programming languages, where the programming languages, if you like, is the data or state associated with the component. Now, in general, a component has some state associated with it, and that state may have different values, and the value associated with the state may impact on how the component displays on the screen. And you as a developer would make that decision as to how you want the component to render based on the current value of the state associated with that component. Now, the state is, so the state could have different values, and each state value we refer to as a different story for that component. And so, sorry, what I'm saying, stories are, yeah, deciding on A, what is the state part of a component, and B, what are the different values that state may have, and C, how does the value change how the component should render. That's really all part of the design process for a component. So if we take the dynamic languages component that we've developed so far, primitive and all as it is, maybe I've decided that there are 3 different stories or states that I want to associate with this component. One is, let's say, the normal state, when the list of languages is, let's say, less than 5. I've arbitrarily decided if there are 5 or less languages in my list of languages, then I want the component to render the way we've seen it already on the screen. My second story might be, well, what if the list of languages is empty? Do I just want the component to be blank? Or do I want it to be display some sort of error message or just normal message? So I've decided if the array is empty, I would just want it to display this on the screen. So it's more informative to the user. The user may think that the component isn't working. And I've decided on a third story, which is if the list of languages is greater than 5, then my component should list the first 5 languages, and also have a kind of button that allows the user to click on and paginate through the various languages in the array. So I've just arbitrarily decided these are the 3 stories or states that I have designed for my dynamic languages component. What the Storybook UI will do for you, now you've actually obviously got to code this, all right, and I'll show you how to code it in a minute. You've got to implement these stories somehow. And when you do implement the stories and associate them with the particular component, then the Storybook UI will reflect that in what you see on the left here. So underneath each component, it will list the various stories. And now by clicking on a story, it will show you how that component renders for that particular story, provided you've coded up the component appropriately and you've written the story as well. You do have to implement the story. Thirdly, before we start looking at how we implement stories, for a very large React project, you might have quite a long catalog of components that make up your application. And rather than kind of listing them in a long linear list here on the left, it might make sense to group the components into groupings. And you want those kind of groupings to be reflected in the Storybook UI. And so you will get this kind of visual effect when you do that. Again, you've got to tell Storybook which components belong to which group, and I'll show you how to do that. But now you have the ability to see the group, and you can collapse and expand the groups, see the components within a group, then click on a particular component, see the stories associated with that component, and eventually click on a story to see how the component actually renders. So this is Storybook for developing individual components within your overall application. Now, by convention, there's one story, the stories for a particular component are implemented in one file. And by convention, the extension for those story files is .stories.js, although I've looked at other articles and they use a different file extension, so it's not that significant, but this is the one that we'll use. So every .stories.js contains all of the stories for a particular component in your code base. That's how you structure your code. Now you have to follow a particular pattern in these story implementations, and I'm showing you an excerpt here from the stories implementation for my dynamic languages component that we've looked at so far. So clearly I'm importing React. Also, I am importing my component, which looks like it's been implemented over here. Now, in this file, you've got to have a default export and named exports. The default export has to be an object structure, and the properties of that object are prescribed. Sorry. One property is title, and you can really put anything you want in that string, but typically it should inform the user as to which particular component it relates to. So this string here, that is actually what appears on the left-hand side of the Storybook UI. When I was describing the Storybook UI, I said it was the component name, but it's not actually the component name. It is this string here, which clearly should be very close to the component name. The second property just refers to the actual component itself. That has to be the default export, and the Storybook server uses this default export to decide how it should list components on its left-hand side. Then you have named exports, and the named exports, you have one for each story. So a story is actually implemented, as we can see, as a function, and I'm just decided to use the arrow style, but you don't have to. The story function itself, it can have any logic that's appropriate, but it must return an instance of the component. And that's what I'm doing here. And I'm referring to my component using the HTML-like syntax rather than just referring to the component function name itself. Now, we haven't seen it so far, but we'll see it in a few minutes. What I'm actually doing here is this is how I pass data into a component. You can see here what I've done is just declared an array with strings in it, which are my languages. And then I'm passing those languages down into my component. This is normal kind of HTML, if you like, because these are attributes in the HTML, in the language of HTML. These are attributes that I'm associating with this element, if you like. Now we'll see later on how does my component actually get at this data that's being passed into it. But in terms of stories anyway, you implement your story as a function. Function has to return an instance of that component, and presumably, how you constructed that component in terms of the data that you pass down to it, that is relevant to the particular story itself. This looks like the story based on the name that I've given it. This looks like the story where the number of languages is between 1 and 5. I probably should have used a different name here, but this is just a variable name. So this is the implementation of my stories. And so when I start up the Storybook server, part of the configuration of the Storybook server is to tell it where my stories are. And it essentially then reads through all of the story implementations. It kind of gobbles up all of that code. Within the story implementations, it will be able to get access to components because, for example, in this one here, I'm telling it where this component is. So it then goes away and grabs the components implementation. It transpiles everything for us, and it sends all of that code down to the Storybook server. And the Storybook, sends all that code down to the browser. And then the browser just renders kind of what I showed you back here, renders this kind of stuff for us. Let's go back to components now, and we'll use Storybook as we work our way through the remaining slides, because in the remaining slides, what I want to do is to go back to components, talk about how we do various extensions of our component code, but we'll demonstrate all of that using Storybook as well. So we'll kind of juggle those two aspects. Now, so what I'll provide you with is, again, a kind of a code base. And this code base is going to be the basis for the first of this week's labs. The second, if we go back to the website again, there are 2 labs this week. First one is all about React basics, but I'm going to be using Storybook in order to get you to work through some of the basics of React. The second lab involves using the Vite tool. It's actually quite long, but it's very kind of prescribed and you'll just be following the steps. Whereas in this lab, it's more exercise based, where I get you to implement a small component, number of components. And then you can see whether your implementation is working or not by using Storybook. So in terms of this lab here, your starting code will look like what you're seeing on the right. And you can see in my source folder, I've got a component subfolder, and I've broken that down into exam exercises and samples. And inside of both of these subfolders, I have, in the exercises one, I have a number of components, but they're just shells. There's no body to them. You've got to implement them. And in the samples folder, I've got implemented components that demonstrate various aspects of component coding that we want to work our way through. So you can see a number of them here. And down here, then, I've got a stories folder, which is subdivided along the same lines, because I need to have a story file for each of my sample components. And I've also provided the story files fully implemented for your exercises components that you're going to have to write. Although you will need to just glance at the implementations of those stories in order to help you to implement the component. So let's actually pull that code into VS Code. So now, again, this folder you will get when you go into the actual lab. It's not the archive, but when you go into a lab, the very beginning of that lab, you'll be asked to download a zip. And when you unzip that archive, this is what you will get. And the structure is what I showed you on the screenshot there. So again, just to confirm that. Okay, and I've got my stories here, and my samples, and so on and so forth. And in the exercises, various components, but they're all the same. See, they all need you to complete the implementation. Now, in terms of starting the Storybook server, I've made it easy for you. I've gone into package.json. If we go back to that file that I mentioned at the beginning, in the package.json, as well as listing the third-party libraries, just before we move on to that, actually, you can see here there's quite a number of the storybook tool itself is broken up into a number of third-party libraries. So you can see here me pulling in various parts of it. And as before, I'm also need to bring in React and React DOM. Bootstrap is just a CSS library that I use later on. We're not too interested in that. In the package.json, you can also have what's called a scripts section. And in there is where you put in, you document kind of shorthand versions of commands that you will need to execute from the command line. So in particular, if we take this one here, this is the command that we will run when we want to start the Storybook server. If we wanted to start the Storybook server kind of longhand, then we would type this command into from the command line. Now, it's not very long, admittedly, but this is essentially just a shorthand version of that command for us. So if I run my Storybook command, and the way you do it from the command line is you go npm run, and then the script. Now, when I hit return here, what you'll notice down at the bottom is the Storybook server will start consuming all of this code over here. Now, how does it know where to find? I said the first thing that it does is it finds the stories first. How does it know where to go looking for the stories? You know, it doesn't. It's not kind of hardwired to go looking for a folder called stories in your source folder. That's not the way it works. The way it actually works is dictated by this .storybook folder up here. This is where you put your Storybook configuration. Now, you will never need to go near configuring Storybook. This is default configuration that I've provided for you, and so you won't need to make any changes to it. But just briefly if we look at the main.js, inside here, I tell it where to find my stories, and that's essentially kind of what I'm doing here. Telling it to go look into the source stories folder, and any file that ends in .stories.js, that's where my story implementations are. So the Storybook server uses this file to pick up my stories, and once it has the story implementations, then, as I was saying a while ago, that also in the stories, I'm importing the components. And so it now has everything that it needs it has everything it needs to work out what should actually appear on the Storybook UI interface. And so if I hit return down here now, it doesn't work. Freudian slip. Now you can see the activity happening at the bottom of the screen. That's where it's actually transpiling, and suddenly, voila, we get our Storybook UI. And if I click through, here I've decided to break them up into two groups. I have a samples group and an exercise group, which kind of makes sense for this particular project. But if I look through my components, as I click on them, and each component, as it turns out, only has, well, bar the last one, they all have only one story associated with them. I kept it simple, but as I click down through them, it's rendering the component for me. Whereas when I click on the exercises components, they're all in the to-do state, if you like, and you have to implement those components, as I said. So that's the context for the first lab, and it's also the context for the remainder of this lecture. The first thing we'd like to know is, how can we embed variables in our JSX? Up to now, our JSX has been purely static. And the answer to the question, how do we embed stuff in our JSX, is it's actually similar to the way you use it in string templating. If you use the curly braces to wrap either the variable reference, or it can be an expression as well, you can embed that in your JSX, and the runtime will evaluate what's inside the curly braces first, and then insert the result of that evaluation into your actual JSX. So if you see the sample code that I'm showing you here, it's a small step forward now, but either way, you can see here I'm just declaring inside. This is my component. I'm declaring my array with languages, and I'm also declaring a string with that assigned to it. And down in my JSX, I'm referencing these variables. So here we go, where I reference the header variable, and I'm actually embedding. So the outer curly brace is here, this curly brace and its corresponding closing curly brace. This is the JSX embedding that I'm talking about. Now, in my case, between the curly braces, I have a string template, and the string template is using the header variable. So if you like, the string template is an expression that first of all has to be evaluated by the runtime, and then the result of that evaluation is inserted into, well, it's technically, it's going to be a child of my H1. Then I've got some I've got a UL list, and I've got some LI elements, and in the LI elements, I am accessing my languages array that I've defined up here, and I'm just indexing into elements within that array. So the overall point is, use your curly braces. That's how you embed variables or expressions in your JSX. We're told to refer to component samples 02, and what you'll see there is the exact code that I'm showing you here. So that's the component samples 02, sorry. That's the component, but the corresponding story is probably what we're interested in as well. Now, obviously, the numbering that I've assigned to the files should help you to relate stories to components. So if I go down into the samples subfolder and the 02 stories implementation, just for convenience, I've given all of the files the exact same name bar the prefix numbering. That's just for convenience sake. Normally, the story file name, I guess it would make sense that its name should somehow reflect or be related to the component that it's linked to, but it's not in this case, but that's okay. So if we look at the 02 story implementations, I only have one story, and it's a trivial thing, right? This is the story implementation here. So that's the first thing we've learned about how to embed something in our JSX, how to embed variables or expressions. If we want to make our component reusable, so far our component has been completely static, and also it's not reusable. Like if we wanted to change the list of languages, for example, there's no way we can do that other than going into the source code and changing it. Now, there are a number of ways of making a component reusable, but for today's discussion, one way is to pass parameters into our component, and typically, although not exclusively, those parameters will relate to data that or state that component uses, but we'll see later on, it can be more flexible than that. Parameters can be more flexible than that. Now, in the language of React, parameters are referred to as props, which presumably is short for properties. And there are two things that we need to know. A, how do we pass props or parameters into a component? And B, how does the component access those props internally? Well, this is how we pass props or parameters into a component, and you've actually seen it in passing already. So it's very kind of HTML-like in terms of attributes. So it's whatever name you want to give to the prop, followed by its value, and the value must be enclosed in curly braces because this has to be evaluated first before it can be assigned to the prop, if you like. And then you just keep on going with whatever number of props the component requires. By the way, deciding what components a prop should have is part of the component design process. So I'm kind of conveniently ignoring that for now, but it is part of the design process. So that's how you pass props into a component. Second question then is, how does the component actually refer to the props? Now, by default, a component function has a parameter, which I'm showing you here. Conventionally, we refer to the parameter as the props parameter, but you can give it any name you want to, but we may as well stick with the convention. And this props parameter is instantiated by the React runtime, and it will instantiate it with an object where that object's keys are going to correspond to the prop names that you've specified up here. And the values associated with those keys will clearly be the value that you assigned to the prop. So this thing here is going to be an object with key value pairs. And you can see here what I'm doing is I'm just accessing particular properties within my props object in order to get at the actual value. And presumably in the JSX, then I use this value embedded in my JSX. What's very important to remember is that props are immutable. So, okay, this looks like an ordinary object that I have access to inside here. So you might think that inside here I could use props dot prop1 name and assign a different value to it. And syntactically you can do that, but the runtime won't honor that assignment statement. It just won't allow you to change the key value pairs within your props object. Hence, we say it's immutable. And that was a conscious decision made by the React engineering team that you could not mutate props within a component, because props are things that are passed in. So it's whoever's passing in the prop, they have the power to change the prop values, okay, but the component itself does not. And as I said, deciding on what props is part of the design process. So we have an example of props being used in the 0-3 sequence. And if I look at in this case, if I look at the story first, it's the same kind of dynamic languages component that I'm using now, though I have a different implementation, obviously, because this implementation is expecting props. There is only one story, and here we go. I'm declaring my array of languages. I'm also, as a prop, I'm going to pass in the heading that I want to associate with this array of languages, in this case, modern languages, let's say. And here I am passing the props into my component. And then if we look at the component itself, then we're told, look, it's implemented over here. So if we find the component, here's my component, here's the props parameter of my component function. And, here I am dereferencing the prop within my JSX. So my component is slightly more reusable now in that I can pass in a different array of languages every time I want to use this component, and a different kind of heading for what those languages represent. And just to see the component rendering, that's props and one aspect of reusability. Before I talk about the next kind of component feature, I'm just stating here now that it's possible to assign, or it's legitimate to assign a piece of JSX to a variable. That's actually going to be, even though it looks kind of odd, that's a valid statement to have in the kind of React world, if you like. Now, if you think about it, how come that is possible? Well, the answer to why this assignment statement is possible is if you think about how this is actually going to be transpiled, because everything has to be transpiled at the end of the day before the browser can actually execute it. And if this is what I was really talking about at the beginning of this lecture, this simple assignment statement here, when we transpile it, or when it is transpiled, it turns out to be this code down here. And so this now looks like an ordinary assignment statement. I'm assigning whatever create element returns to this variable. Now, create element has parameters to it, and the parameters also happen to be invoking react.createElement. And this is similar to when I was nesting invocations of react.createElement within invocations of react.createElement. I was doing that at the very beginning, if you remember. So that's the explanation as to why an assignment statement that looks like this, which is kind of declarative in nature, is legitimate, because at the end of the day, it gets transpiled to this. So taking that on board, next thing we're going to look at, and it's a very common occurrence, is where we want to generate a list of components that are all identical in shape, but they have different data associated with them, if you like. So that's our use case. We want to generate an array of similar components from a data array. And there's a common little pattern that we use to achieve this. So if we look at the sample, which is the 0,4 one, and in the 0,4 sample, essentially what we want our code, our story to do, I suppose, is to generate, our component to do, what we want our component to do is to generate a set of Li elements programmatically. So if we look at, let's see how it renders first, maybe. So this is the 0,4, and it's rendering a list of, in this case, single page app frameworks, and these are actually hyperlinked as well. And the story, if we look at the story first for 0,4, so here's the data that I want to pass into my components. So I've got an array of objects, and each object has a single page app framework name and a URL for that framework's documentation page, let's say, or documentation site. And I've also got another variable as well with just a string attached to it. Here's my component, and I'm passing my two variables down to my component. Now, what I wanted to do, though, is what I want my component to do is to take this array, and for each entry in the array, I wanted to generate a hyperlinked element, and I want those elements then to be within an unordered list, if you like. So if we look at the component itself, so props.frameworks is referring to my array of objects, and I'm mapping over that array. And we know what the map function does. It goes through each element in my array, and it calls the callback. It invokes the callback for that element. And my callback in this case is returning a piece of JSX. So that means that this array here is going to be an array of Li elements. And this will actually work because these Li elements, when they get transpiled to what I've already explained, they get transpiled to. So we really are just declaring an ordinary array here where each array contains a value, and the value is whatever is returned by react.createElement for this little bit of JSX. And then, so list is an array of JSX elements, and then I'm just rendering list down here. And so what I've highlighted there now is, and I've wrapped it, sorry, now just 1 second. Sorry. I've wrapped my list inside a UL, which makes, from a HTML point of view, my LI elements need to be wrapped inside a UL element. So from a HTML point of view, that all makes sense. So this entire line, this entire line here is what generates, you know, my list of hyperlinked, hyperlinked text strings. Now, this pattern of taking an array and mapping over the array and the callback to the map function, returning JSX, that's something that we'll see quite a lot of throughout this part of the module. So you may need to go back and study that yourselves in your own time to make sure you understand the code. And just in terms of the whole dynamic nature of this, you know, if I go back to the story, and let's just arbitrarily build up my array a little bit. So if I grab all of this, and assuming there are no syntax errors, all I'm demonstrating here now in a moment is the live reloading aspect of the Storybook server. So once I save this change, and assuming there are no errors, and I go back to my Storybook UI, you know, it has updated the component rendering for me automatically, because it has pushed the updated story down to my browser and so forth. So components return JSX. That's the rule, right, that you have to follow. And the JSX can be anything you want to. So maybe a component returns another component as its JSX, or more generally, or more commonly, a component returns a multi-line piece of JSX. If it is multi-line, you do have to wrap it in parentheses. That's just to help the runtime interpreter, really. But other than that, you know, a component can return any simple or complex piece of JSX, but it has to return only one element. So if you take this example here, this is not going to work, because what I'm returning here is a H1 and a my component and a paragraph. I'm trying to return 3 different elements. And the reason this doesn't work, again, goes back to how this transpiles. This will really transpile into trying to return 3 different results of invoking react.createElement. And no matter what language we're talking about, you know, a function or a method can only return one thing, whereas here we're trying to return 3 things. Now, this is a very simple problem to fix, though. But if you don't fix it and you leave it like this, then you will get this runtime error appearing in your browser, and you may come across that. And the error message is fairly informative. It's essentially kind of telling you that you're returning multiple JSX elements from a component, and that's just not allowed. And so how do you solve the problem? It's quite simple, really. All you've got to do is just wrap this sequence of elements, wrap it in a div, and now you've got a single element that's being returned. So it's a simple solution, and it's one that we use quite a lot. Now, the upshot of that, though, is we have to kind of artificially include a lot of divs in our components just to satisfy that requirement. And so in a very large application with lots and lots of components, all of which is going to contribute to the browser's DOM data structure, which we were talking about at the very beginning, it means that that DOM data structure is going to have nodes corresponding to all of these divs. And the only reason the div nodes are there is to satisfy the React constraint. But in a very large application, that may mean that your DOM tree is a much deeper tree structure than it really needs to be. And really, the bigger the DOM data structure, that's obviously going to impact on the browser's performance in terms of re-rendering the DOM every time it changes. And this was a problem in the early days of React. And the solution was provided by the React team themselves. They provide us with a new tag called the fragment tag. And you'll see me using this a lot. This is how the fragment tag looks and its corresponding closing element. And what's nice about the fragment tag is that it does not have any representation in the DOM structure. So it's only there. The fragment tag only exists in the React world, if you like. It doesn't exist in the DOM world or in the HTML world. Now, this is a big statement, but it's true. All React applications that you will ever develop is going to finish up as a hierarchy of components. You can't get away from that. So, in other words, components can have other components as children, and that depth, that nesting can be as deep as you want it to be. And we know, of course, that props are things that we pass into a component. So what you will see is components having other components as children and passing props down to those children components. Just by way of illustration, I have a sample 5 illustrating it. Again, it's kind of made up example, but in my sample 5, this is what I'm trying to achieve. I want to have 3 components, which one of them is the parent and the other 2 are children of that parent. And the numbering system that I'm showing you there is kind of reflecting the parent-child relationship, where 1 is the parent. So it looks like the component that's represented by 1, it has 2 children, and obviously it passes data down to those 2 children. It also has the parent component also has some of its own JSX, so it generates this bit of JSX itself and this bit of JSX itself. So here's the story file, and I've got my array of languages and I've got my array of frameworks. Now, for no particular reason, what I decided to do was to construct a new object which brings the 2 arrays together. That's all that's going on here. And then I'm passing that larger object into my component. Again, that was just an arbitrary decision. I could have instead passed down the 2 arrays as separate props down to the component that I'm testing here. The component code itself, then it needs to obviously deconstruct this larger object that's passed into it. So here's the component code. I'm importing the 2 child components that I'm using, that this component is using. And here it is actually invoking, if you like, the 2 child components, as well as having some of its own custom JSX. So this idea of a component using other components within its JSX to facilitate what the parent wants to render, this again is a very common pattern, this idea of a parent-child relationship and having a hierarchy of components, where in this case my hierarchy comprises of 3 components, a parent with 2 children. There's always going to be one parent at the very top of the hierarchy, but the depth of the child relationships can be as deep as you want it to be. So I'm summarizing in this slide what we've learned so far, but I do want to cover one other topic now in this lecture before we finish it completely, and that is I want to look at a third-party React CSS library called Material UI. Material UI is a third-party library for developing React apps, and we've used it in the second library linked to the first lecture. And I just want to give you some background to it. We'll be using it throughout this module, so it's pretty important. Back in 2010, Google took it upon themselves to come up with a set of principles or guidelines or standards related to the design of user interfaces for both native apps and web apps. And what they drew from was not so much what was best practice in that world at the time. They actually turned their attention towards classic design principles. In other words, how real world textures and surfaces are represented on pen and paper, how we represent light and light reflection and shadows, etc. And from that, they came up with a kind of a vocabulary that we could apply to user interface design. But also not just those classic principles themselves, but how can those principles be enriched and enhanced through technology and indeed science. And the collective label for this set of principles is what they call material design. Material just being a metaphor in the sense that it came from real world classic design principles. So that's quite high level, but they took the set of principles, if you like, and from that they derived what they called a set of components or material components, which are really kind of building blocks. They use the word component, which is not necessarily linked to anything related to React, but it's more building blocks is how you should think of this slide. And they have 5 categories of building blocks. So this is where it becomes, as I say, linked back to user interface design. So one category of building blocks is what they labeled display building blocks. In other words, how do we structure the content of a web page? And so we use concepts like cards and grids and lists, which you're familiar with, and we'll be using those in this module via the Material UI third-party library. Navigation is obviously an important part of a web app or native app. So there are some core components or building blocks defined by the material design document, which we can leverage. The 4th category there, obviously inputs are a very important part of any web-based app, and there are core components linked to that, and communication building blocks or components as well. So the material design system is a set of principles and a set of building blocks that allow us to realize those principles, but there is still a lot of flexibility available to the individual, and that comes in the form of theming. Google did not simply want us to copy the way they do things. Now, by theming, we mean what kind of color scheme you wish to use, what kind of typography you'd like to use, and that's all kind of a branding that you might want to associate with your website, which is unique to your website. So there is still that flexibility available to you within the overarching kind of material design principles and building blocks. Although they do recommend that in relation to color, that you should have what they categorize as a primary color scheme and secondary color scheme. Again, just to achieve consistency from page to page from a coloring point of view. And you can define what is primary and secondary for your particular application. In relation to typography, they actually defined 13 different typography styles, which really kind of fit all possible scenarios. And you should pick a subset of those and use them across your, or at least the material design system is recommending this, pick a small subset and use that of typography styles and use them consistently across all of your pages. And we'll see that again in this module. So where Material UI comes into the picture then is Material UI is a React-based third-party library that is linked back to the material design system set of principles. And so if you did begin or if you did complete the lab from last week, and you will see in subsequent lectures that we will be using components from this library which are linked to those building blocks that I mentioned there. So we'll have a card component, box, grid, etc., etc. So rather than us trying to design these ourselves, we can just pick them from the library and tweak them. By tweaking, I mean you may want to slightly modify the default styling associated with them. As well, the Material UI allows you to define your own theme, although I don't get into that in the labs, but you may wish to read up on it yourselves. Now, the components, the third-party components that you will use from the library all come with their own default styling. But as I mentioned there, you may wish to tweak that styling a little bit. So that means obviously CSS in the case of web apps. So the Material UI team decided that they were going to use what's called the CSS in JS model as a way of allowing us developers to customize the styling of a Material UI component. Now, just to explain how this works, first of all, if we, on the left there, if we didn't have this CSS in JS approach, which is something we can use independently of Material UI, by the way, but if it didn't exist then and we wanted to style some JSX, then how we would approach it is what you see on the left. We would write our custom CSS in a CSS file as normal. And then we apply that CSS to our JSX element using the class name. We import the CSS file into our JavaScript file, and then we use the CSS rule, if you like, which I've defined up here. We use it using the class name attribute, which we've seen already. So that's, if you might call, just plain CSS application. With the CSS in JS model, this is how you can approach it. You can actually write your CSS as a JavaScript object, which is what I've got here. So this here is the equivalent of my CSS over here, but this is coded as an ordinary JavaScript object inside my component file, if you like, which is a JavaScript file. And to apply that CSS to a JSX element, I use the style attribute, and I just simply refer to the object that I've defined up here. I refer to it, obviously I've got to, because I'm embedding a variable in my JSX, I wrap the variable name in curly braces as before. And that has the exact same effect as what we see on the left. Now, you can't write just any old attributes that you want to inside this object. The attributes have to correspond to the equivalent attributes in the CSS world. But, and the but is important, you've got to use camel case for those attributes. So for example, background color spelled like this is the equivalent in CSS as background hyphen color. You cannot use background hyphen color over here because the hyphen is going to be interpreted as a minus, and so the JavaScript runtime is confused. It thinks you're trying to carry out some sort of a subtraction operation. So you just need to remember that whatever a CSS attribute is called in the CSS world, you've got to convert it to camel case in order to use it in this CSS in JS approach. And other than that, then it's pretty straightforward, really. If you did use camel case here, the Babel transpiler is actually clever enough to pick it up and realize that that isn't going to work. So you will get a warning message about it. And it's as straightforward as that, really. And you'll see this being used now quite a lot in our code when we're trying to customize the styling for Material UI components. Now, in terms of lab work for this week, so as I've mentioned once or twice already, there are two labs. The first lab is dealing with Storybook, and the second lab is looking at the Vite tool. I haven't covered Vite that much in the lecture, but that's not by accident as such. This lab is very prescriptive. It isn't. There isn't a whole lot on Vite that we need to know. So what's going on behind the scenes? We do use Vite quite a lot, but it's one of these background tools that just takes care of stuff for us, so to speak. But in this lab anyway, I do step you through creating a Vite project and using Vite for things like building a production version of your app. So see how you get on with both of the labs. The first one is really exercise based. The second one is prescriptive and just follow the steps if you like. Okay, see you in the next lecture.